And if yes, which scheme would reduce waste disposal more? Now, given that we've all learned about the fundamental principles of economics, we should straight away say, well, both of them will end up having some positive effect on reducing the amount of waste disposal, but the one that has more incentives built through marginal cost should result in more recycling or less waste disposal, right? Clear? Let's look at the actual empirical results. As I just suggested, both schemes should reduce the amounts of waste and increase recycling, and we would expect the one with the clear incentives associated with the marginal cost to actually do better, and surprise, surprise, and this, by the way, this example is not cherry-picked. I didn't pick this out simply because it works. I picked it out because economics works, and because people respond to incentives. And that's exactly what happened here. The per can program reduced the non-recycled, or the waste disposal, reduced it by 20%. The more incentivized pricing mechanism actually reduced the non-recycled waste by 51%. So it turns out that, yes, you can change people's behavior if you create the right incentives through governmental policy. That's the conclusion of this particular experiment. Now let's look more generally at the efficient level of recycling. All we did through the prior example is say, gee whiz, we can provide incentives for more recycling and less waste disposal, but we didn't provide you with the framework for determining what is the efficient amount of recycling, right? And that's what I'm going to turn to here, namely, how do we go about measuring the efficient level of recycling? And by the way, anytime someone asks you the question, economically, how do I go about determining the efficient level? If you go back to the first part of the course, whenever we talked about economic efficiency, we talked about what market outcomes maximize total surplus. The market outcomes that maximize total surplus are economically efficient. Now, when we're looking at environmental economics problems, once again, when we come to how do we go about determining what is the efficient level of waste disposal, or the converse, namely, what is the efficient level of recycling, we have to go about finding the relevant demand and supply curves. But now, the relevant curves are the marginal benefit curves, which is our surrogate for demand, right? And the supply curve is our marginal social cost. If I can construct the marginal benefit curve and the marginal social cost, I can determine the efficient level, right? So the real challenge is not to jump to what the efficient level is. The challenge is, how do I go about constructing the marginal benefit curve? How do I go about constructing the marginal social cost curve? And if I can get those two curved, I'm home free, right? Right? So the real challenge that you will face in the future in applying these concepts, and what you'll face with regard to the challenge on the final, is how to go about properly constructing those two curves. And once you got them, you're going to be able to easily determine the efficient level. If not quantitatively, you can do it graphically, right? Okay. Now, I want to identify the efficient level of recycling, and as I just said, I want to find two equations or two curves if I'm doing a graphical analysis, the marginal benefit of recycling and the marginal cost of recycling. Now, what constitutes the marginal benefit? The marginal cost of recycling is simple. It's straightforward. The real thought experiment is how do you go about constructing the marginal benefit of recycling. And it should occur to you intuitively there must be at least two sources of recycling. One, given my silver example, right? I can recycle silver and sell it as virgin silver material. So that's one possible benefit. I better take that into account, right? Secondly, if I recycle more, that means that that amount of product is no longer finding its way into waste disposal sites, no longer dumped on the side roads, no longer polluting the aesthetic environment, because it's being recycled and used. So isn't that a benefit, too, of recycling? So given that intuition, right away, my challenge is to construct these two sources of marginal benefit. Now, the first source is very simple, because all I have to do is know what the price of the virgin material is. The second source, with regard to the damages avoided by recycling, right, because that's what I just said, correct? I'm going to avoid the damage of disposing of this waste, and instead I'm going to recycle it so it doesn't end up in landfills and polluting the environment. So what I'm doing is avoiding those environmental damages, and that's a benefit. Okay? All right. Given that intuition, the marginal benefit must recognize, as I just indicated, the price of the virgin material. There's an active market for that. Right? And secondly, the social marginal cost of disposal that's avoided by recycling. Okay.
So when you take into account these things, what about also when you recycle, you decrease the demand for the original production of virgin material, which should also avoid how much energy is being used on it and the effect of pollution out of that, pollution out of that. Right? Because there's less production of the material. If you consume less energy, it would decrease pollution to the environment.
You know, it makes total sense. What you're saying is that the private market for the virgin material doesn't reflect the social optimum amount of virgin material that's being produced. That's what you're saying. And you're saying that if I do more recycling, that means there's going to be less demand for the virgin material, and I will substitute the recycled material for the virgin material, thus there's less production. And if in that production process it generates environmental externalities, I'm avoiding those externalities. Okay, I can do that here, but I'm trying to simplify it. Okay, no, you're quite right. I'm presuming, and lying behind the analysis I'm about to go through, is that there are no externalities associated with the production of that virgin material. Then I'm going to relax that assumption, and we'll complicate it a bit more. Okay? Are we all together? All right. So the social marginal cost of disposal is the private waste processing cost and the negative externalities, the health hazards, the landfill, and those negative externalities can be aesthetic losses, damages to human health from the waste, and that's particularly a problem with regard to two recyclable materials, namely lead and mercury. And the social marginal cost that's avoided by recycling has to be considered as part of the marginal benefit of recycling. Okay? Now I'm going to show you everything that I just said in narrative form graphically. Well, maybe not quite yet, but almost. Minerals. The price of virgin materials. This is very straightforward, just recognizing that there is some virgin material that has a market price, and this point about subsidization will end up, if you end up with more supply, then everything else constant, there's going to be more waste disposal. And recognizing the social cost of the additional waste disposal, which would result from more subsidization of the basic production of the virgin material. All right. Now let's move on to the actual graphic analysis. Okay. What I'm going to represent here horizontally is the percent recycled. And this is going to be value or the cost and prices associated with the percent recycled. The marginal cost of recycling is easily computed. Many people make this measurement all the time with regard to what society faces with regard to the incremental cost of recycling more and more. Let's suppose that this horizontal line is the selling price of the recycled material. That is a constant price. I can sell silver at $5 an ounce, for example. And if I don't recognize the externalities, the private sector will end up equating the marginal cost of recycling with the selling price of the recycled product. Right? That is the private marginal benefit. And it turns out that the optimum privately would be Q subscript P. That, however, is not the efficient amount of recycling because it doesn't take into account the avoided damages that emerge from waste disposal. And that's the next step, is to look at the marginal social cost of waste disposal. And clearly, as the amount of recycling goes up, the incremental marginal cost of waste disposal declines. But to get to the actual marginal benefit of recycling, I have to add the price of the virgin material, which is this horizontal line here, to the avoided damage from recycling instead of waste disposal. So if I sum this horizontal curve with the social marginal cost of waste disposal, I end up with the social marginal benefit that I seek. And once I have that curve, I can now, since I have the marginal cost of recycling and I have the social marginal cost of recycling, this is now the efficient point. And that would be the efficient amount of recycling. Right? Make sense? Now, I've also included a narrative explanation of this particular graph, first defining what's on the horizontal axis. And the real thought that is required in preparing this graph is to fundamentally understand the social marginal benefit of recycling, because that social marginal benefit is the avoided marginal cost of waste disposal. Right? And that's what I'm recognizing on the left-hand side of this panel. And if we didn't take that into account, we'd end up with a private market solution, which is clearly socially inefficient. But once we do recognize it, we can get to the social amount, optimal level of recycling. All right? Let's take an active learning example. It's very straightforward. Let's suppose the marginal cost of recycling of a particular waste is $20 a ton. The recycled product can be sold for $10 a ton. Should society recycle this waste? That's the question. Visit with your neighbor. Shouldn't take you but a moment. Okay, Andrew, what's the answer? You have to assume it's under or over. You said both. Over, yes. In other words, I haven't given you full information to answer this question. It should be, tell me what the marginal social cost is that I'm avoiding by recycling. If you tell me that, then I can tell you whether I should be recycling this waste or not. Right? So in answer to this question, it depends on the social marginal cost of waste disposal. And if that social marginal cost is greater than $10, which is I think what you said basically, right? Then society should recycle the waste because it would be in their interest to do just that. And if we suppose that the social marginal cost of disposal is $20 a ton, then the benefits, the incremental benefits are much larger than the incremental cost of recycling. So it's a simple conclusion, namely I should recycle. However, if that social marginal cost were $5, it'd be a different story, right? Yes?
What would you do with the social marginal cost of that $10?
I would then determine, that would be equating the social marginal benefit at 20 to the social cost of recycling at 20 and determine what amount of waste I should be recycling at that point, right? Okay, so for this example, if in fact the social marginal cost is $20, I certainly should recycle this waste. Now, why are the recycling rates induced by the private market too low? They're too low, quite obviously. We've constructed this showing that they're too low in large part is because the private market doesn't take into account the avoided incremental cost of waste disposal. And the private market, as a result, is going to move too far in the direction of waste disposal instead of recycling. And that's going to result in using more of the virgin materials. So we have no choice but for the government to intervene to try to change the incentives that exist within the private sector to create more in the way of consumers engaged or households engaged in recycling. Yes? Okay? Right? Okay, so how do we go about internalizing the social cost of disposal? Many communities have looked at this question, agonized about the right way to proceed, and the natural direction of the public discourse is to charge the full cost of disposal for recyclable products. And that, they would argue, creates incentives for the individuals to recycle at an efficient level to avoid the disposal charge. But that also requires huge enforcement costs on the part of government. And those enforcement costs in detection about households or individuals that are avoiding the disposal charge. And you can avoid the disposal charge on recyclable materials by treating it as a non-recyclable material, right? Throw it into a receptacle for non-recyclable. And the enforcement costs, you would have all your trash collectors having to go through and monitor to see whether in fact it's a recyclable material or not, and it's never worked effectively. And the conclusion of all of these communities, and what we've learned over time, is that you have to design a self-enforcing mechanism. And that self-enforcing mechanism is to, in effect, create a market and some incentives for recycling the material. And the classic example is a refundable deposit. That's a self-enforcing policy. In the case of batteries, when you buy an automobile battery, you pay the purchase price for the battery, and you pay a deposit. And that deposit is supposed to be held by the vendor for you to return the battery once it's been effectively used and is no longer productive. When you return it, you get back that deposit. That is a self-enforcing policy, and the refund is claimed whenever that product is turned in for recycling. And if that deposit is set, if it's set at the social marginal cost of waste disposal, it should provide the right incentives for the efficient level of recycling, right? Because that's the price that a household or a person is going to see with regard to returning the product to collect that deposit and to create the incentives for them to recycle rather than to dispose of the product as waste. Here's an actual example. A number of states have passed what's referred to as bottle bill legislation. And I've listed the states here. And in each case, the retailers collect deposits from consumers. If consumers or unemployed homeless people collect these deposits and take them back to the retailer, they get some fee for recycling that material. And what has been the result of this legislation? The recycling rate throughout the United States is approximately 40%. Now we're talking about bottles, right? We're not talking across all recyclable resources. The recycling rates in 11 states that have passed this legislation is twice as large. It's 80%. And if you look at Michigan, that has very large incentives for recycling, namely a deposit that's set at 10 cents, their recycling rate is 100%. Right? So the key challenge on the part of the public sector or the local municipality is how do you set that deposit rate to take into account the marginal social cost avoided by waste disposal that becomes a benefit for recycling. All right. The next, and this is the last thing I'll do, and I've already mentioned this, the cost of a new car battery is the price of the battery plus a $10 deposit. When you return the battery, you get back the $10, and as a result, 90% of used batteries are in fact recycled. Right? Thank you.